In continuation with talking about dynamic program approach for solving problems, we'll continue the topic by solving another problem called as flow shop scheduling. So let us see how we can solve this scheduling problem using dynamic program. So a few basics on flow shop scheduling. As you have already studied your operating system subject, you already know what is CPU scheduling. Okay, this is also a similar thing like CPU scheduling, but this is called as a flow shop scheduling. So this will be the general structure of a flow shop. There will be a set of processors or machines, assuming that there are m number of processors represented as P1, P2, P3 and so on up to Pm. There will be given m number of processors or machines. On these processors, n number of jobs have to be executed. Job number 1, job number 2 and so on up to job number n, and these jobs have to be executed on the given processors. Now each job is not a single unit, but it comprises of a set of operations which are called as tasks. Each job comprises a set of operations. Assuming that each job comprises of m tasks, which are represented as T1i, T2i and so on up to Tmi, where T1 is task number 1, T1i represents task number 1 and represents job number I, which is represented as T1i, task number 1 in job number I. Each job consists of a set of tasks. So this is ith job. It comprises of task number 1, task number 2, task number 3 and so on. Each job consists of a set of tasks. And the rule is that all these tasks must be executed in an order. If I want to execute some job number I, then I have to execute task 1, task 2 and task 3 in that order. The order of the tasks must be followed. Once you execute all these 3 tasks, that is nothing but executing job number I. And this is first rule, first constraint of scheduling problem, that the tasks must be executed in the given order. Then second rule is that if there is task 1 has to be always executed on processor number 1. Task 2 has to be executed on processor number 2. That is, task J has to be executed on processor number J. So these are the 2 constraints that need to be followed while scheduling the jobs. So as I said, task Tj must always be executed on processor Pj. And the tasks within a job must be executed in the order. Then, while assigning tasks to the jobs, each processor at any point of time may execute only one task. You cannot assign more than one task to a processor at the same time. So following these constraints, for the given set of processors, jobs and tasks, you have to generate an optimal flow shop schedule. So defining what is a schedule. A schedule for the n number of jobs is an assignment of tasks to time intervals on the m processors. That is, given n number of jobs, m number of processors. If processors are m, so it is implicitly understood that the number of tasks are also equal to m. Now, whenever these n jobs have to be executed on m number of processors, you have to come up with a schedule for the n jobs, and that is nothing but assigning the tasks to the time intervals of the process. And a schedule will look like this. After scheduling, your schedule will look like this. Job number 2 is executed first, then job number 5 may be executed, then job 1 may be executed, then job 4 may be executed, and so on. So if I'm writing like this, then it's called as a schedule. So we have to prepare this schedule in such a way that it should be executed. All the jobs must be executed in minimum amount of time. So I am here, this is the schedule which says that job 2 has to be executed first, then job 5, then job 1, then job 4. So a schedule will give you the order in which jobs will be executed. And when you calculate what is the amount of execution time for executing these 4 jobs, then it should be minimum amount of time. The execution time should be minimum. So I can say that this is a minimization optimization problem. Now we'll try to solve this using dynamic programming. So in general, what is scheduling? How we can schedule? Let us see. You already know this. We are going to draw some Gantt charts. So assume that this is the given information of the problem. There are 2 jobs and 3 processors. That means there are 3 tasks also. And the information, the time for executing the job and the task is given as a 2 by 2 matrix, where the matrix representation goes like this. Columns are the jobs, rows are the tasks. This is how you'll have to interpret the given matrix. Columns are jobs, rows are tasks. If I'm writing this particular value is 211, that means it is task number 1, job number 1. And if it is, say, for example, T32, it is T32. That is, it is task number 3, job number 2. This is how you are going to interpret the information. Now, taking this information, I'll have to schedule. I can come up with different types of schedules, but the challenge is to generate an optimal schedule. Right? So for that, I'll give you 2 possible schedules because there are only 2 jobs to be executed. So the order of job execution can be either I'll execute first job number 1, then job number 2, or another schedule that is possible is I can first execute job 2, then I can go for executing job 1. So these are the 2 possible schedules. 2 possible schedules. Now among these 2 schedules, whichever gives me minimum finish time, that I will treat it as an optimal schedule. So I'll first start the first case where the scheduling order is job 1, then job 2. So starting with the schedule, I have 3 processors. This is a multi-processing environment. So there are 3 processors. So I have drawn 3 Gantt charts, 3 charts for 3 processors. Each of this chart represents the time of processor. This is chart for processor 1, chart for processor 2, chart for processor 3. So as such, if there are n number of processors, you have to draw n number of charts. And now, always the execution time or the start time starts with 0. Then I'll have to start scheduling the tasks. There are two jobs. And each job has task 1, task 2, and task 3. And I have to execute them in this particular order. I have to execute task 1, then task 2, then task 3. Task 1 has to be executed on processor 1. Task 2 has to be executed on processor 2. Task 3 has to be executed on processor 3. Right? So these are the constants that you have to follow. Now, starting initially at a 0th point of time, all the 3 processors are free. All the 3 processors are free. Now I can schedule. I can always schedule task 1 only, because only after executing task 1 can task 2 be executed. So I'll always start with scheduling task 1. So here the order is job 1, then job 2. So I'm scheduling task 1, job 1 first, and then task 1 of job 2. So task 1 will be always executed on processor 1. So I have scheduled like this. Now check out the information. How much of time task 1, job 1 is taking? It's taking 2. Right? So that is what I'm going to write here. It says 0 and a 2. Okay. Then task 1, job 2. How much amount of time it will take for execution? It is T12. T12 is here. That is, again, it is taking another 2 time units. So I'm writing here, it is 4. This is schedule for executing task 1. First, I have scheduled job 1, then I have scheduled job 2. Now, until the first 2 time units, processor 2 will be free. The gray shade shows the idle time for the processor. From 0th time unit to 2nd time unit, this processor is free, because it can start its execution only after task 1 is finished, then only T2 can start. So at least 2 time units, this processor has to wait. Okay. Now, after T1, J1 is finished here at the 2nd time unit, further I can schedule T2, task 2 of job 1, which starts at 2nd unit, because task 2 has to be scheduled only after task 1. So task 2 will start here, and it will end at 5th time unit. How much time it is taking? Task 2, job 1. This is T21. T21 is this value, which is 3. So it's taking 3 time units from 2nd time unit to 5th time unit. It's done. Once this is done, the processor 2 becomes free. So I can schedule another job, another task, right? So I'm scheduling T2 of J2. T2 of J2 is taking another 3 time seconds. So you can see here, T2 J2 is taking another 3. Okay, so then coming to processor 3. Processor 3 will be initially idle for the 5 time units, because P3 can execute only T3s. Task 3 can be started only after task 2 is finished. Then only task 3 of job 1 can be scheduled. So I've scheduled here starting from 5th time unit, and it is ending at 7th time unit. That is, it is taking 2 time units. This is because in the given problem, T31, the value of T31 is equal to 2. Then finally, this will be again idle time for the processor 3, because task 3 of J1 is getting finished at 7th time unit, but it cannot immediately start a T3 of J2 because T2 after finishing, then only T3 can start. So T2 is getting completed at 8th time unit. So T3 can start only after 8th time unit. So this is the schedule for processor 3. So finally, the two given jobs are getting finished at 13th time point. The first job is getting finished at 7th time unit. Second job is getting finished at 13th time unit. So if I see here, this was my schedule. The schedule was 1, 2. That is, the order of job execution is job 1 will be executed first, then job 2. Then the finish time is represented like this. F1 of S indicates finish time of job 1 set S, which is represented as F1 of S. For the schedule S, what is the finish time of job 1? So job 1, you can see here, job 1 is finished at 7th time unit. That is, if you want to consider when job 1 is finished, within job 1, task 1 should have been finished, task 2 should have been finished, task 3 should have been finished. All the 3 tasks must have been finished, and that will give you the finish time for job number 1, which is equal to 7. Then finally, what is F2 of S? For the schedule S, what is the finish time for job number 2? So you can see here, job number 2, T1 is finished here, task 2 is finished here, task 3 is finished here. You have to consider after all the tasks have finished, then only job 2 is finished. So which is finish time for job 2 is 13. Now, what is the finish time for the total schedule? Not individually for each job, but for the schedule, what is the finish time? Now, you consider this 7 and 13, whichever is maximum among these two, max, that will be taken as the finish time for the schedule. Then you can calculate the mean flow time for the schedule, which is the average of the finish times. F1 of S plus F2 of S divided by 2. The average of the finish times will give you the mean flow time for the schedule. That was where the schedule was 1, 2. Now I'll take up another alternative schedule that is possible. And the schedule is S is equal to 2, 1. That is, job 2 will be executed first, then job 1. Now check the finish times. So you can see here job 2 is first scheduled. Here also job 2 is first scheduled. Here also job 2 is first scheduled. Then job 1 is scheduled. So the order of job scheduling is 2, 1. Now what is the finish time? The finish time I can see here that J2 is getting finished here. J1 is getting finished here. So that is finish time of job 1 is 12. Finish time of job 2 is 10. What is the finish time for the schedule? The maximum value. So among 12 and 10, the maximum value is 12. So this will be the finish time for the schedule. And the mean flow time, take the average of the finish times. Now you can observe, you can compare which schedule is optimal schedule. I have first scheduled 1, 2 in that order. And the finish time was 13. The finish time was 13. And then I'm going to schedule 2, 1. And the finish time is 12. So whichever schedule gives me the minimum finish time, that can be treated as the optimal schedule. Now, among the two possible schedules, this schedule is giving me minimum finish time, so it will be treated as optimal schedule. So the optimal schedule is 2, 1. Now, you cannot go on with brute force approach. The technique that I have applied here is brute force approach. Brute force approach is the situation where you'll explore, you'll generate all the possible schedules and calculate all the finish times, which is practically not possible. If there are more number of processors, more number of jobs, generating all the possible schedules, calculating all the costs will take more time. So we are going to apply dynamic programming approach and will generate only feasible schedules. We'll explore only feasible schedules, among which we'll select one schedule as optimal schedule.